So we completed the chapter 8. Now let's proceed to chapter 9. Yeah, see, did you guys do the 6th question? What was that? I think no one have done it. Otherwise, you would be having question on it. Said DB create file destination to Oracle Home Aura Data U05 in memory only. What does it mean? Can anyone who have completed the task?
That is only for the current session.
How? How you did it? Every guy said here they have completed this practice session, right? So let me know how you have completed this question 6. Anyone? Come on, guys. I don't know. You said you completed the chapter, right? What not practice means? You said you completed everything. Osman,
Yeah.
you completed the question 6?
No, I did not.
Rohit,
Yeah.
you completed the question 6?
No.
Shamad?
Nope, I did not.
Okay. But at least guess what it's saying. What you have to do. Just guess.
It will create in memory only.
How? Hello, Vandana.
Hello, hi.
You completed the practice session?
No, not completed yet.
Not even a single question?
No, I will ask tomorrow.
Why? I mean, yeah. Are you facing any difficulty in creating or what?
There are lots of problems.
Oh, time problem. You are not getting time.
No, there are lots of problems.
What problem you are facing? At least if you are facing any technical difficulty, at least let's discuss so that you can do it.
I can't understand what are the table space at all.
I think you missed a few classes, right? That's why.
Yeah.
Yep, that's why.
Me too.
Me 3. So don't miss the classes. That's why. It's very important. If you will miss one class, next class you won't be able to understand anything. Not even a next class. Entire thing is dependent upon that. Whole database is dependent upon table
So
space.
for this, would you do
Yeah.
like when we were doing P files and SP files, we were doing scope.
Right.
Like for example, increasing the memory.
Mm-hmm.
Would that be something similar to that? Because since we're specifying memory only, so it would be some kind of a scope that we have to do, I guess.
All right. Sorry? What did you say? So you have to set db create file destination. So you have to run alter system set db underscore create underscore file underscore dest is equal to this path and scope equal to memory. So let's run it. I don't have my virtual machine. Can anyone share anyone share your screen?
I have mine on.
Okay, just share.
So does memory mean, what does memory exactly referring to here?
Yeah, that's what I will explain it right now.
Okay. Can everyone see?
Yep.
Okay.
We are just seeing your PDF. We are not seeing your virtual machine.
Oh, wrong screen. That's my
Yeah.
other screen. Give me a second. Stop share screen.
You can use entire screen.
How about now?
Yep.
Okay. This is my
Yep.
first screen.
So command would be alter system set. Your database is running from P file or SP file first.
P file.
Yep. So now you have to set DB create file dest in memory only. Means, what does it mean by in memory? Until you are not restarting the database, these settings will be in effect. What is memory? Whenever you are starting the database, memory gets allocated. When you bring down the database, when you shut down the database, memory gets deallocated. So if you will set any parameter into the memory means scope equal to memory, then it will be in effect until you are not restarting the database. The moment you will restart your database, it will take the parameter from the P file or SP file, not from the memory. So now run your command alter system set. DB underscore create underscore file underscore test equal to single inverted comma, give the path /u02, or it's asking Oracle home, right? So assume your Oracle home is /u01 or u02, whatever it is. Just assume it. It would be something different, but and put anything. Do you have the that folder created at the operating system level?
No, I do not. So I have to create that first.
Yeah, first create on operating system level.
Okay.
Just create whatever document is saying. Just create it to Oracle home.
Oracle home Aura data user file.
Right.
So we would put a -R to make it in one another.
No. First go to Oracle home. Dollar Oracle underscore home. Enter. Yep. Now do pwd. Yep. Now here you can create a one folder Aura data. mkdir Aura data. See the PDF. Aura data should be in capital. Yep. Enter.
Yeah. Aura data. Where is that? Yep. Aura data user 5.
Yeah. Enter. Now go to Aura data, cd Aura data. Now create U05 here, mkdir U05. Yep. Now do pwt. Yep. So this is the location you have to specify there.
For data and then U05.
Yep. Go to cd U05. cd U05. Enter. Then do pwt.
Do I need to zoom? Someone ping. Give me a second. I think this place not find mobile. Oh, okay, that's a C. Alright. Alright. So copy this location. Alright. So I'm gonna give that location here. Alter system set DB create file destination to that location.
Scope.
And
Give the space. Scope equal to memory.
so
Right. System altered. Now do show parameter db underscore create underscore file.
destination.
That's it. Just enter. So it's showing your current path U01 app Oracle product 1124 db underscore 1 or data U05. You have set it on the memory label. What would happen if you will restart the database?
It won't be there.
Yeah, so let's verify. Restart your database.
My bad. Nothing there.
Yep. So that was set for the memory only. Memory only means until and unless you are not going to change that value or you are not restarting the database, it will be there. Clear?
Yeah.
Now you can verify the creation of the data file. I mean, you can create the table space and you can verify all the information. Okay, now let's go to next chapter. I'm sharing my screen now. Storage structure and relationship. Now we are able to understand how Oracle physical and logical storage are associated with, how table space and data file are associated with. Now next we will read about that how data are organized into table space and data file. Now we know at least what is data file and what is table space. Now what's the structure of them? After completing this lesson, you should be able to do the following. Describe the logical structure of the database. Right now we studied physical structure, now we will see the logical structure. List the segment type and their uses. What are the segments and how do we use? List the keywords that control block space usage, obtain storage structure information. So let's come to the storage and relationship structure. So here you can see this is your database. Database name is prod, right? in one database you can have multiple table space. The mandatory table space is system. So here you have system table space. Here is the user data table space you can create. Here is the rollback segment, means undo table space, and here is your temp table space. If you want to create more table space, you can create more. But these are the mandatory: system, undo, and temp. These three table space are mandatory table space. You should always, system, you cannot deny it. By default it will get created. RBS means undo also gets created. Temp you can deny, but you should create it always. And if you have to put any user data, you have to create user table space. As we know, in one table space there may be multiple data files. So we can see here in user data it have two data files, disk2 user1.dpf and disk3 user2.dpf, and rest table space have 111 data file. Now inside that data file, how things are segregated? So those are segregated into the segments, and segments are nothing, it's just the object which you have created. So suppose you are creating a table with name salary table, then a segment of salary table will get created into the data file. Inside the data file we don't say it table, we say it segment. It's the segment of the table. Same way you can have different segments. So each table would have one segment. Suppose you are creating table HR address. So you created a table HR address, but inside the data file it would have a segment of HR data. And now that segments are divided into multiple extents, and further those extents are divided into Oracle data blocks. So that's why we say Oracle data blocks are the lowest unit of physical attribute. It's not physical, but it's a unit. So if you have one data block, then it can have one extent, then it can have one segment, then it can have one data file, and then it can have one table space, then it can have one database. So that's the hierarchy of your database. Block means DB block, extents, segments, then table space. That is the logical, and in physical you have data file. Clear? Or any doubt, any question on it? Any question?
So just so I can, if I understood this correctly.
Mm-hmm.
So within the table space we have data files, and within the data files we have segments. Anything we do within the data files is considered segments.
All right.
I'm a little confused about.
Your voice is cracking. Yeah.
Oh, those are actually, okay, so there's different types of table. Now I understand. Sorry. Okay. I'm good.
No. What was your question? Where it was confusing?
No, I was just trying to understand the graph, and I understood it as I read through it now.
Yeah. So these are the tables. One is table, one is index. So those are the segments. Now this one table have two extents. Extent 1, extent 2. This index have two extent. Extent 1, extent 2. And this two extent have 4 data block. 1, 2, 3, 4 data blocks. So one extent have 2 data blocks, one extent have 2 data blocks. Let's see somewhere on Google so that it will be clear. Oracle physical structure. You can see here. So you have one whole database. Inside that you have multiple table spaces. In any table space you would be having different segments, means different tables. You will understand in the another way. Different segments mean different tables. But how those tables are organized? Depending upon extents. How much extent it has been allocated. And how extents are get allocated? It depends upon the blocks, actual blocks. Clear?
Yeah, so the structure definitely makes sense. But from a user standpoint, my question is, when you want to actually look at the segment, are you able to, like, you know how, for example, in the database we create a table space, we can access a table space. Just like that, are you able to access a segment, or are you able to alter a segment, or are we not able to touch that or access that directly?
Not directly, but indirectly you can. Being a DBA, what the user will do? User will just create a table, right?
Yeah.
And then after he will insert the data into that table. But being a DBA, it's your responsibility how those data are being managed. Managed means he created a table with poor storage clause, like poor extent. He allocated extent size to 5 MB, but he is inserting data into extent of 1 MB only. So 4 MB is being wasted when he will be inserting the data. So even his data size is 1 MB, but when he will be exporting that data, a table size would be 5 MB. Why? Because he have poorly written the create table. He have not, as a DBA, we should recommend all these things. So those we will come to the point why extent management is how it will get.
Okay.
noticed.
So in terms of altering the segments, we can only increase or decrease the size of the segment based on the data that we're inserting.
Yep. You will be you created a table space, right?
Yeah.
When you created the table space, did you specify extent management?
Yeah.
What was that?
Whatever you wanted it to be.
Local, uniform size.
And also, was it dictionary?
Yeah, it can be, but mostly we use local. Local uniform size 100 MB. Right? What does it mean? It's saying extent management. This extent management.
Okay.
How it will be get allocated? Locally by table space. Suppose you have filled 5 extent. Now you are inserting a next data. So it needs to allocate one more extent, right?
Yeah.
So what size of extent it will be allocating? 100 MB, because at table space level you have specified it.
So in this case, we're allocating 100 M worth of extents.
Extents, right?
Okay. Yeah.
But 100 M extents will be allocated in chunk of blocks, DB blocks. So suppose 100 MB you are allocating to one extent. So what's your DB block size?
I think by default it's what, 8? Is it 8 KB?
Yeah, run the command. So parameter DB underscore block at your system. (8192) divided by 1024, so it will be 8 KB approx.
8192 divided by 1024 is gonna be 8. Yeah.
So your DB block size is 8 KB, means minimum allocation is 8 KB. So suppose you are going to allocate 100 MB of extent. So how many block you will be getting allocated?
100 divided by the 8.
Right. 100 divided by 8. So you will be allocating 12.5, but not 12.5. You will be allocating 13. It will be always rounded off.
Rounding. Okay.
So you will be allocating 13 block to the next extent. And that extent will be allocated to that segment. Segment means the table or index or whatever it is.
So I'm assuming later on in the class, we're going to discuss how to look into what size of data we're inserting versus the size of the segment in extents.
Right.
Okay.
So when we see overall from the top, we saw from the top that what is data file and table space, but how it gets allocated and deallocated inside that, this is the way, in the form of block, extent and segments. Now types of segment. Here we can see inside the table space we having segments. It may be table, it may be anything. So what kind of segments do we have which are get stored into the table space? We have table. Everyone know what is table, right? The row and column, that's called table. Table partition, it's a special kind of table which we divide into the partition wise. Like if you have sales table, so you can divide it into the year wise. Sales of 2016, sales of 2017. So you can create a partition of that table. So that's a kind of segment. You can create a cluster. Cluster is also a combination of table. By combining few tables, you can create a cluster. Index. Index is used to access the data from the table too fast. Like you have table of 1 million records and its size is suppose 1 terabyte, and if you will be doing select star from something, it will take 5 hours. But if you will create an index on that table, it can fetch very easily with the row ID. So same way, like you read the book, right? So if you have to search anything, first you go to the indexing. Which chapter, suppose I have to see about a table space. So first of all, in the index we will see in which chapter table space has been discussed. Okay, it has been discussed in 8th chapter. Then directly you can go to the 8th chapter. Then there will be address. 8th chapter is at which page number. Then directly you can go to that page number. Same way, index creates on the table's data, and whenever you will be selecting the data from the table, index directly hit to that blocks instead of searching all the table. So these are the types of segments: table, table partition, cluster, and index. A table is the most common means of storing data within a database. A table segment stores the data for a table that is neither clustered nor partitioned. Data within a table segment is stored in no particular order. There is no order, and the database administrator has very little control over the location of the rows within the blocks in the table. So where data is getting stored into the block, you don't know. It's Oracle automatically manages. You can know. In Oracle high availability team, they used to dump the block, they used to read the block, but as a DBA you should not know, and even no one expects you to know that one. All the data in a table segments must be stored in one table space. All the data in a table segment must be stored into the one table space. What does it mean? You cannot store one table into two table space. Means you cannot create one segment into two table space. So all the segments should be in one table space. Same way, table partition, scalability and availability are major concern where there is table partition is just to partition the table putting any criteria. Any criteria means it's up to you. If you want to create the partition yearly, you can create. If you want to create partition weekly, you can create. But what's the benefit of partitioning? So let's see here. Suppose you have a table like this. You have multiple rows, multiple columns, so many things. You have so many data. Suppose you are selecting any data from here, right? So you will be writing a query, select salary from something. So how Oracle reads this table space? It will search all the data, then it will compare with your query that you have a specified salary equal to 5,000. So how it will be able to know? By after comparing everything. Then it will find that this is matching data, and then it will give you the result. So it searches in all the data. If it would be having 10 years of data, then it will be searching all the 10 years of the data. To segregate this, we create a partition table. 2001 data, 2002 data, 2003 data. Table would be same, but it will be partitioned in year wise. So now if I will search, select salary from employee of year 2005. So now it won't search all the table. It directly goes to this partition only. This partition, 2005 partition. It will search in 2005 partition only. So we eliminated how many? 1, 2, 3, 4. Might be we eliminated 50 GB of searching. So it will be very fast, very quick access. That's the use of Oracle partitioning, table partitioning. Now cluster is the same kind of thing, and index, as we know, we create index to get the faster access. All the entries for a particular index are stored within one index segment. So whatever index you will be creating, those will be stored into the one segment. If a table has 3 indexes, 3 index segments are used. So at a table you will be creating one index, it will be having one segment of index. If you will be creating 2 index, it will be having 2 segments of index. And the more you will be creating, it will be having another segments. The purpose of this segment is to look up the location of rows in a table based on a specified key. And this key is the index key. That's why it searched directly onto the block label using row ID. Types of segments. Yeah, go ahead.
Quick question. So is the index, is that something automatically created by the Oracle?
Sometimes it gets created. Whenever you will create the primary key, it gets created automatically. But you can create by yourself as well. The way you create the table, create table name. In the same way you can create index name.
Gotcha.
See, create index Oracle. Go to the town. It will be having syntax here. Create index emp underscore ename. This is the index name on emp ename, means this is the table name and this is the column name. So this index is getting created on table emp column ename, and in table space users, and these are the storage. So that's why you can create separate index as well. If you think your access is getting slower, you can create an index. So types of segment. We have index organized table, we have index partition, we have undo segment, we have temporary segment. Can anyone say what is undo segment? What is undo segment?
If you want to roll back to a previous state, then you can use undo.
Right. So old image of the table gets stored into the undo, and that's called undo segments. What is temporary segments? Right. It's used for the sorting. So whenever you are doing sorting, like whenever you are putting order by clause into your SQL query, then sorting will be done in temporary segment, when temporary table space, in the form of the segments. So those will be stored here. You have LOB segment as well. LOB, as name says, large object. What does it mean by large object? You know, you can insert the rows into the table, but suppose you have to insert the image file, video file. How you can insert them? Can you insert them? No. So you will keep them outside of the database and you will put a reference to the table. That's why we create LOB segment. That called LOB segment. So any image, any video or any JPG, such kind of files called LOB segments. Nested table, depending upon two tables, it joins few tables. And bootstrap segments. Don't much focus on all these, just try to know what are the segments available into the database. Mostly use tables, LOBs, indexes. These are the mostly and commonly used into the database. Rest are rarely used. A storage clause precedence. Whenever you will be specifying a storage clause, first it will look for the segment, then table space, then Oracle default. By default, whatever you have specified. So whenever you are creating the table, suppose in this case we were creating the index, right? Create index this, table space this. Then you are specifying storage. Storage means initial 20K, next 20K, and PCT increase 75. Means initial size of this segment storage will be 20K. But when we were creating the table space, we specified something else, right? So which one will take place in this case? Table space label, or when we are creating the objects or segments? So that's the precedence which use. First it will use at the segment label. If you have specify anything at the segment label, then that will be using. If you have not specified anything at the segment label, so if you have removed this storage clause, you just use this, create index this, then it will use the storage structure of table space, whatever you have specified at the table space level. And if you have not specified at the table label space as well, so whatever Oracle default value is, it will take consideration of that. Clear? No.
Yeah.
Extents allocation and deallocation. An extent is a chunk of space used by a segment. As we know, segments are combination of the extents. So an extent is a chunk of space used by a segment within a table space. An extent is allocated when the segment is created, extended, or altered. So when you are creating the table, a extent will be get allocated, and when you will be dropping the table, extent will be getting deallocated. If you are inserting data into the table, extent will be getting extended. An extent is deallocated when the segment is dropped, altered, or truncated. So if you truncate the table, extent will be deallocated. What does it mean by extent will be deallocated? It will release that blocks. Used and free extents. In a one data file, we have the option of used and free extents means how much extent has been used and how much extent has been freed. So suppose this is your data file, and before this all the extent has been used and these are free. What does it mean? It means whenever new extents will be required, it will be getting allocated from here and will keep allocating until it reached to the maximum limit of the data file. The moment it will reach the maximum limit, it will say sorry, I cannot allocate more extents because I don't have. Then you have to create another data file which would be having free extents. Now database blocks. This is the minimum unit of I/O. As we know that it's a smallest unit for measuring the data size inside the Oracle database. It consists of one or more operating system blocks. As we know, it's the smallest unit, but it's also depend upon operating system block. We won't cover operating system block in this class because that's out of scope of the DBA. Those are the things which are handled by system administrator. So operating system blocks will be being used to allocate data block, and database block are set at table space creation or at database creation. DB underscore block underscore size is the parameter which is used for the default block size. As we see right now in Osman system, the default block size was 8 KB. Means if you are not specifying at the table space, then block size would always be 8 KB. And based on that block size, your extents will be created, and based on those extents, your segment will be created, and based on those segments, your table space will be created. Multiple block size support. From Oracle 9i, it supports multiple block size as well. So suppose by default is 8 KB, but you want DB block size more than 8 KB, suppose 32 KB. So you can use it at the creation time of the table space. When you will be creating the table space, you can specify it, but you cannot change the default value of the DB block size after creating the database. If you have created the database with default block size of 8 KB, that's it. You cannot change it after that. If you have to change the block size, you have to recreate the database. But you can take the advantage of multiple block size support into the same database. You can create another table space which will be supporting different block size. Standard block size set at database creation using DB block size parameter, and it cannot be changed without recreating the database. By default you cannot change, and it used for the system and temporary table space. DB underscore cache underscore size specifies the size of the default buffer cache for a standard block size. Non-standard block size. So you can configure additional cache with the following dynamic parameter. DB 2K cache size for 2 KB blocks. DB 4K cache size for 4 KB blocks. So these are the parameter. If you want to use multiple size of DB block, you can specify this parameter. But don't get confused with this. Just know that DB block size is used to allocate the space to the extents. Don't much focus on this. Creating non-standard block size table space, you can create like this. Create table space name, data file, this, size 10M, block size 4K. So in previous class you were not specifying any block size, right? So your block size was creating at the default, which was 8 KB. But for this table space, it would be creating the block size of 4K. Not 8K. So if in this table space 100 MB of extent will be requiring, how much block will be getting allocated? 100 divided by 4, which is 25 blocks. But in previous our block size was 8 KB. So if 100 MB means 8, divide by 8, 13 blocks. So that's the calculation of the number only, and it depends for the burden of the database, because to allocating 13 blocks, Oracle database have to waste his energy, right? In the same way, he has to waste the energy for 25 blocks. So which one is better? Allocating 20, right? 12, instead of 25. If you have to complete 5-page PDF in one day or 10-page PDF in one day, which one is better? 5-page, obviously. You can read it immediately in 5 pages. Same way, if you will allocate DB block size properly, your database would not suffer with poor performance. That's why 8 KB is the standard block size. Generally you should use as 8 KB. But there are multiple data warehousing tables which need bigger block size, so you can tune them accordingly. But basically, most of the time you will be able to see the by default 8 KB. This is the GUI representation, how you can create database block contents. Come on. Now we know table space, data file, segment, extent, data blocks. Now here it's showing inside the data block. What's inside the data block? So this is the structure of your data block, where if you can see this, so here your data will be get stored. So suppose your DB block size is 8 KB. So this whole size is 8 KB, right? But it does not mean that all the 8 KB is used to store the data. In this, it have header, might be 1 KB will be being used for header, might be it would be leaving free space in case it want to grow, and few space for the actual data. So in header information, it will be storing all the information like which extent it has been allocated, which table space it has been allocated, all those information. And this free space, it keeps free because suppose right now you inserted the table, any record of the salary with 5,000. Tomorrow your salary got increased. Now it need to store 10,000. 1 byte got increased, right? So where it will be increasing if it would not having free space? That's why it always keeps some free space for future growth of the rows or column. So that's the structure of the smallest unit, which is database block. Very difficult, right? Looks like very difficult. Everyone is silent. Osman?
Yeah.
Looks like very difficult, right?
It's making sense together.
Yeah. It's not much difficult, but yes, little bit.
Yeah. So the header here in the block is supposed to be updated anytime there's a change to each individual data block. Is that what the header is for?
Right.
Okay. And then does it have any information about the free space in the header?
Right. It keeps those information as well.
Okay.
So we were studying the memory component, right? In memory, we were reading that you have DB buffer cache. So whenever you are doing any select, these blocks pick from the data file and get stored into DB buffer cache, right? Because actual data are stored here into your block. So whenever you perform any select operation, these blocks picked from the data file and goes into your memory, and inside your memory in the region of the SGA, and inside the SGA in the DB buffer cache. That's why the more data you will be selecting, more DB block will be getting picked from the data file and will be filling your DB buffer cache. So suppose, no, leave that. That will be confusing. So here it is, block header. The header contains the data block address, table directory, row directory, and transaction slots that are used when transaction make changes to rows in the block. Block headers grow from the top to down. And data space, row data is inserted into the block from the bottom up. And free space, the free space is a block is in the middle of the block. Thus both the header and the row data space can grow when necessary. The free space in a block is contiguous initially. However, deletion and update may fragment the free space in the block. The free space in the block is collapsed by the Oracle server when necessary. So that's why these blocks be used into the cache or in select operation or anywhere. Of course, there is no real life implementation of these blocks, extents, you won't be able to see them. But if you will be going to higher level, like if you have to tune your database for performance tuning, your database performance is degrading, that time you should know about this, how extents, how DB blocks, how segments. But in initial stage you need not to be worried about this, but you should know at least what are these, because in an interview everyone would be asking what are extents, what are segments. But in physical life, practical life, these are rarely used. Mostly you have to deal with table space and data file. Creating the table space, moving the data file. Those are the common DBA tasks. But for the conceptual thing, you should know how it gets allocated inside the data file. Block space utilization parameter, and there are lots of things. Init trans, max trans, PCT free, PCT used. So you can control this data blocks using this parameters. Getting overloaded? Guys, getting overloaded?
No. I mean, I always, whenever we go, I mean, it's so interesting that even to the database block level, you can customize to your liking based on your business needs.
Yeah.
And to me, it's always interesting, like the minds that created this, man, they have to be geniuses to come up with this concept. I mean, to understand it is one thing, but the one who created it is like amazing.
And he is ruling the all over world.
I know, that's right.
So these are the parameters. When you will be creating, you can use it. PCT free, PCT used. So we will be skipping this right now, because right now you have to understand first these concepts. Data block management. There are two methods are available for managing data blocks. One is automatic segment space management and one is manual management. Now in table space you were reading whether it's whether it's local managed or dictionary managed. But what was that? That was extent management. How extent were being managed, locally or dictionary. Here we are seeing segment, automatic segment space management or manual management. So this is the method of managing the data block, not the extents. At table space level, we used to manage extents. Here we used to manage data blocks. Automatic segment space management. It is a method of managing free space inside database segments. Tracking in segment free and use space is done using bitmap as opposite to using free list. This method provides ease of management, better space utilization and better performance for concurrent insert operations. So you can specify like this. When you will be creating the table space, create table space, your table space name, data file, this is the data file, size, your extent management, local uniform size 64 KB. Then now you have segment space management for data blocks. So if you want to use auto, just put auto. After a table space is created, the specifications apply to all the segments created in this table space. So whatever segments would be creating into this table space, that will be using automatic segment space management.
So in that statement segment, that is standing for block space.
Right. All right.
Okay. All right. Got it. So that this actually the statement itself actually clarifies the structure, like starting from the table space, you size that, going to the extent level, then sizing that, and then managing it locally, and then going to the block level, I guess.
All right. Exactly.
All right. Cool.
So I understand that the segment space management, organizes the data blocks.
Yeah.
But what exactly is it doing? Is it taking the unused data blocks and kind of recycling them and not letting them go to waste? Exactly what is it doing with the data blocks?
Right, the same thing. Like suppose you created a table, you inserted 500 rows, right?
Yeah.
Next day you deleted 200 rows. But those blocks are already attached to any extent or any segment. How will those will be getting freed?
So this segment space keeps going back, like periodically checking to make sure there's no the data blocks that are not being used, and then refreshes them and then frees them up or something.
No, it does not refreshes that. To refresh, you have to use CLASS, but it just keep the tracking of them. It keeps the information of that.
So in your example, let's say you had 500 data blocks that were being occupied, and then you kind of go back and you delete 200. Now you have 200 data blocks that are not accounted for.
Yeah.
So does this tool basically goes back, and what is it doing? Is it taking that 200 back and putting it back into
No. It won't do that. It will just keep the information that you have 200 free blocks into this segment. So next, you have the scheduler job into your database, which perform CLASS operation. So when your scheduler will be performing the CLASS operation, that time it will release all these 200 blocks and it will deallocate it.
Okay, so this tool is only identifying. In order to free it up, you have to enable that. What did you say?
CLASS.
What's that other?
CLASS.
Okay.
Yeah, it will come here. See.
DB schedule. Okay, cool.
Yeah, that was the automatic. If you will be using manual data block management, then you have the option to configure data blocks manually using parameters such as PCT free, PCT use, and free list. In the DB block, we were seeing few parameters, right? So,
yeah.
If you will be using manual management, so manually you have to specify PCT free, means how much percent of free space a data block should be having, how much percent of used space your data block should be having, and what would be the free list. But if you will be specifying it automatic, those will be managed by Oracle database, Oracle server. So what's the meaning of this? When PCT free, PCT use, PCT increase, or whatever it is. So the use of these parameters, just how to allocate data blocks. Means suppose you inserted 500 rows and those are get stored into the one block, right? But your block get completely filled, 100% filled. The next day you are updating the records, but it's unable to fit into that block. What would happen? It will go to the another block and it would be row migration or row chaining. Let's understand.
So what this management actually does is that so it manages how the rows are stored in terms of processing their information. So instead of doing it all in one block, it would allocate it to all over. So when we do the query, it would be able to find it quicker and respond faster.
Partially.
Okay.
Generally, it's inside the DB block how space are getting managed. So this is your DB block, this is your header. Hold a second, where is E? Suppose this is your header and this is your data and this is your free space. So segment space management handle these things. How much space you need free into this block, that's called free list. How much data is free into your data region, how much data is free into your header region. So whenever header want to grow, it can grow. Whenever data want to grow, it can grow. But when it can grow, if it would having free space, so someone will be tracking how much free space. So if you are specifying auto, Oracle server automatically track it and will manage it. But if you are specifying manual, then all these percentage you have to manually allocate. PCT free, you have to specify. Suppose this block is 100 MB. So if you are specifying PCT free, 10 means 10% of the 100 MB will be free to accommodate the future growth. So generally it's the managing of this block. So nowadays most of the blocks are automatic. The only method available in previous Oracle versions. Manual data block management. With manual database block management, you can configure how block space is used and when a block is available. Parameters such as PCT free, PCT used and free list are used in manual management. Previously, this way the only method available for managing data blocks. In previous version, means previous to Oracle 9i, there was no automatic management. The only method was PCT free, PCT use and free list. So whenever you are creating, you have to specify PCT free and PCT use. I have remember I think 6 or 7 years back when I was giving interview for TCS, the guy asked me, the first question he asked, what is PCT free? That time I was having 5 or 6 year experience, but I was not aware what is PCT free. And even someone will be asking today as well, I won't be able to explain much practically because there is no practical implementation of it. It's just to understand how Data means how the space are organized inside the data block. You rarely interact with this data blocks, rarely. If you are a DBA, never. But if you will be working in support, then you can interact with it. So you can see here, block space use. So here is your block. If you are specifying PCT free 20, means 80% can be used and 20% can be free. If you are using PCT used equal to 40, means 60% can be free. That's the way to manage your DB block size. Obtaining storage information. Information about storage can be obtained by querying the following views. DB_extends to know about